So today I'm going to present crop harvest forecasts via agronomy-informed process modeling and predictive monitoring. I'm in fact quite glad that Sanders went into that much details of process modeling, so because I won't. We have similar aspects. So let's go into, and I'm from Australia, my name is Güvençlik. So let's go directly into the background. So crop growth is a dynamic process with phenological events. Here you see in the diagram there that it has phenological stages and phenological milestones. Like in the rice case, it has a vegetation period, reproductive period, and the ripening period. So all we are trying to do with this process, we are trying to we are trying to predict the harvest and yield of the crop. So by using these things. So our motivation is to make predictions that are reliable and timely, and figure out the harvest time, predict harvest time, and the yield. Because crop growers rely on predicted harvest dates to make decisions about their practices, crop growth practices, and also decision makers in the companies in production, procurement, sale operations. They need these predictions to make their procurements, for example, of seeds. How much seeds do they need throughout that year? So this is a very important problem in the agriculture domain. The challenges is, though, in that process I tried to explain at the beginning, I guess I'm a bit excited. The challenges is, when a crop is growing, there's lots of variability and uncertainties. The first challenge is climate variability, which is very unpredictable these days, and especially our case studies in Australia, and the climate is very erratic there. So this has become a real problem there. And geographical location affects how your crop grows, as well as soil type, water quality, availability, and the crop management practices. These agronomists, they look at what's happening, they follow their gut, and they decide their practices. They change their practices throughout that growth process to increase the yield. So giving them some predictions at right times will improve their decision-making process. So yes, and we want to do this reliably and timely. That's our objective. And it's a continual effort, as I said, because you can't have one prediction. If your crop is gonna grow within 90 days, 120 days, you'll have to take predictions at different times and manage your practices. And growers and agronomists, they are scarce resources. So let's assume your company is big. You have hundreds of hectares of farms, and you have one or two guys or ladies, agronomists, going at the field every day, sampling and trying to come up with what will be my harvest date and what would be my yield. That's a hard problem. So our solution to this is we are proposing a systematic and data-driven approach to supporting online, real-time forecast on crop harvests. So, and we want to do this automatically and progressively throughout the crop growing seasons. So our approach, I'll show you a full diagram soon, but when we started this project, we ended up with these data sets: crop production data, which is coming from a company, crop development data, crop environment data. Environment is geographic locations. Crop development data is related to seed type, soil, and other things I'll be showing you soon. And the problem is how do we integrate these data sets, and how do we do that systematically? That was a real problem because we didn't have any agronomy, agricultural knowledge when we started this project. And again, our output we are seeking is data harvest and crop yield. So here you see those data sets I mentioned. Some of the I won't go into details, but these are some of the attributes that we deemed useful. And then we simulated this crop growth process, and I tried to mention at the beginning. So you saw it: vegetation, phenological phase, tillering, reproductive, flowering, ripening. So tillering is, for example, is the transition from vegetation to reproductive stage. And predictions change. So you may get better predictive outcomes when you are in the reproductive period of the crop growth because you have more information. Some time has already passed. You might have had a high temperature during vegetation, so you know that. So predictions gets better as you walk through this process, and I'll be presenting some results about that. So again, we simulated that process, and we end up with, our objective was to create event logs. And it looks something like this. This was a difficult process because, again, we didn't have agronomic knowledge. Once we do that data fusion and simulation, we end up with completed growing traces or set of events and ongoing crop growing graces. By ongoing, I mean we have data sets and we have some crops on the field. We use that data too because these are information collected online already. In an SAP system it was. So we were able to also collect the ongoing crop growing traces. And we used ongoing ones to test our approach to make real-time predictions. And we use completed crop growing traces to train our predictive model. Let's move on. So this is our full approach. The bucket prefixes, encode prefixes, and train models that's well known, like from the literature. We adopted that approach, but the fact that we had to use agronomic information, we tweaked a little bit what is known in the literature, and I think I forgot to put reference there. I'll show you at the end. So that's a well-known framework to make those kind of predictions. And so in the first bucketing, as a bucketing strategies, we use phenological stages, milestones, and in encoding mechanisms, which is sort of innovative in this case, we use agrometeorology principles. So you aggregate data in different ways, especially like for crop growth, there are like crop growing days. So it's not, there are interesting statistical things we had to do there, which was different, and the details is in the paper, so I'm not gonna get into that today. And we trained normal linear regression models, that was a pragmatic decision. And our case study. We worked with a local private farming company. I won't disclose the name because this was a highly confidential project. And I won't also disclose the crop we focused on because it is very competitive. If I disclose the crop, you would know which company that is in Australia. So that's why I use rice example. We are certainly not doing this for rice, but you can practically do this for other crop types. And the company operates across East Australia, which is a massive continent itself and massive land, lots of seasonality shifts. It's not same season. And they have got 800 active farms, but like one farm is like 100 hectares, 200 hectares. like crazy. And they split and dice those farms. So, and our process is relatively simple, just a linear chain. It has 2 milestones. Again, I'm not disclosing it. These are just variables, placeholders, PF and HA. And we have 2 stages, phenological stages. And again, we try to predict harvest date and yield. So we use crop production data from between those years, and crop environment data was publicly available. And after the data fusion, we ended up with 348 completed crop growing graces, historical data, and that many events, over 22,000. And these are, these are normal processes that are done in the literature. We split up our data for offline training and online predicting, made all the tests, which I'm not going to go into details today. And we end up with 2 buckets. So we want to predict these potential harvest dates and yield in the first phenological stage of the crop growth, and in the second, after PF. Let me show you. So we want to have at least one prediction before milestone PF, and we want to at least have at least one prediction in the milestone before milestone HA, including the information gathered during the stage 1. All right, these are some interesting objectives set by the company, which might be useful for anyone who may do work similar to this. So the company said, we would be happy if you could predict our harvest date within the range of ±2. And for the yield, they were happy if it is ±35% of the actual yield. Because in fact, they can't really predict yield. There is a lot of variability. So we are trying to close this gap. If we continue working with these guys, we are expecting to reduce that objective in their mind to 20% plus or minus. Because knowing yield is affecting all your supply chain, downstream supply chain decisions. And the earlier you have that information, the more time you have to take actions, corrective actions. And again, our evaluation measures are quite straightforward. Mean absolute error for the harvest date, and mean absolute percentage error for the predicted yield, and adjusted R scores. All right, let's have a look at our first and second model, bucket 1 model and bucket 2 model. Once again, we use linear regression. So for harvest date prediction, we found our models performing quite nicely because data collection is in fact quite good. There wasn't many noise. And as you are in the second bucket, the error reduces. That's even better because, as I said, we are using the information from bucket 1. We know more, so we can make better predictions. But again, that was through our consultations with the company. We wouldn't be able to figure that out without consultation experience, discussions. And for the harvest date, this crop takes 11 weeks to grow. So as early as week 6, our predictive model is successful, performs well. Like as early as week 6, we can get within 1.77 days of deviation. So we achieve our two-day the set objective by company as early as week 6. So we were happy at this stage. And then we just wanted to diagnose what's going on further. We created some clusters on completed crop growing traces. So we made like 50-day, 60-day clusters and 70-day. And we saw that for 50 and 60-day clusters, do I have, no. Here, for 50 and 60-day clusters, we are okay, we are good. But for the 70-day, you can see this bump, and it is as late now. We are in week 10. We don't have good predictions here. Like, at least we are not achieving the set target. And through discussions again, we figured that 70-day cluster is unusual for this crop Y or X, doesn't matter. So there's a lot of interventions by the agronomists which changes the course of, how crop grows, but this is a failure anyways. The yield is gonna be probably low for these cases because the crop suffers from longer temperatures and more days is more risk. So that's why, that is the reason why this is a bit off. And company was happy. So that's what we were after. And the yield prediction, this was one of the hardest thing. Our models does not perform as we expected it would. In the first bucket, we are not meeting the company set criteria overall. And in the second bucket, we are okay, but we are very close to that 35% mark, so, But the issue is the company didn't have proper data collection practices, and they overlooked many things that might have affected our predictions in many ways. So I'm not gonna go into details, but like many data were missing. Like there were many, columns filled with same data, like lots of noise kind of stuff. So that's one of the reasons why we sort of failed there. But with our continual effort, we are pushing them to adopt some, better data collection practices. This is an ongoing project, by the way. I think I have talked about everything here. So again, we looked at weekly evaluation. We were not happy here on week 9. We are over. This was unexpected. So normally we expect from week 6, which is a milestone, our predictions to go better. But at this stage, it wasn't. Thank you. And again, we created some clusters to see what's going on, what might be going on, and I explained some of the reasons why. For the under-delivered cluster, we created 3 clusters here, over-delivered. This is so company sets some expectations. They say, okay, we saw this crop here. We want the delivered yield to be this many kilograms per hectare. Okay, they set some expectations, and then something happens at the end. We end up having this much produce. So, and when we make comparison between like delivered quantity over ordered quantity, we can create different clusters here. So in the under-delivered case, our predictive models does not perform well. Because again, something is going on with the crop. There has been either lots of rain, high temperature, and these agronomists go like medical, doctors. They try to increase the yield, like at the final stages of growth. So there's a lot of human intervention there. So that's the reason why in this cluster, we figured that our predictive models may not be performing well. So again, this is about good data collection practices because they don't trace every intervention they apply in the data set while they are collecting data. I think I've talked about everything here, and then I'm gonna sum up. So our approach is generic. So the data fusion I discussed at the beginning, it's automatic. We don't, so it's generic and flexible. So you can just change the process model for different crops, but then automatically you can merge these data sets following that process model and come up with your traces, event log, and train and retrain models. So it is flexible. And we would like to try some machine learning techniques. The reason why we use linear regression was because these guys love it. They have already lots of models in the literature, in their literature, agronomy literature. So we followed their advice to use normal statistical models. They didn't wanna use machine learning techniques. But we tried some stuff. It didn't end well. And we didn't have enough time. But we believe machine learning can be useful, which we would like to explore. And so also the use of process modeling in our approach and multi-source data, this one is important, I believe. Like making this automatic is what matters, because we could put this in a web app and progressively give them the predictions they need. Different people in the different places, in different parts of the company, they can reach these predictions and use this data. And future directions, we would like to do some, we would like to extend our case study, and we would like to include crop development data. That's the intervention I was talking about. It wasn't good quality. So we couldn't really use that crop development interventions. And they're not capturing it that well. And we would like to integrate our approach into larger decision workflow. Having said that, although this is future directions, we are already doing this. So since this was prepared, we already have a web app, in fact, and they are using it. And we are integrating these decisions with operations research techniques, which is my background. So we are using these predictions already in larger models to optimize supply chain. So this is already happening and being developed and happening. And here is my team. So I was the presenter, and these two people, they are the kings and queens, and Arthur and Paul Corey. I'd like to thank my colleagues and everyone who has been here, listened to me. Thank you very much. Before I finish, this was a large project supported by Queensland Government, Food Agility CRC, and QUT, which is Queensland University of Technology, my university, and I'd like to acknowledge inputs from Miranda and David. They're agronomy specialists. And that's it, guys. Any questions? Thank you.
Any questions?
Yeah. Thank you. Yeah, thank you.
Thank you for your talk. You said you used some domain knowledge on ongoing traces in the predictive step. Can you tell something about what kind of knowledge is used? How is it used?
The agronomy knowledge you are referring to?
Yeah. And another question.
Yeah.
Did you evaluate whether using this knowledge brings some advantage with respect to not using this knowledge in the prediction step?
That's an
phase?
Interesting. Let me start from that. Not using means this company will be using their field agronomists, and we already compared their performance, and we are already about the same level as they are. Our set targets is their targets. So to start with, we are already there. And if we improve their data collection practices and what we suspect might be useful for predictive models and training and, I believe will close the gap. And this is also important for resilience. We would like to do this regularly. And again, one cannot, like a human being, cannot evaluate millions of things happening all at once in even one field, let alone 800. You know, you need a good, like, 20, 30 agronomists to be constantly in the field. By the way, this is not to replace these agronomists. We still need them to do all this work and use our predictions and their expert knowledge. So not using costs are high. And your first question was the specialty. Yeah, so there is a big literature on crop development and crop management practices. It's an insane, like, literally literature. We weren't able to process everything and figure out something. So what's the specialty knowledge there is, up the top of my head, is crop growing, what was it? Crop degree days, which is you somehow aggregate temperatures in a way that affects your predictions. Normally, let's say, I don't know, if we take means or this or that, they don't do it like that. There is some cumulative kind of aggregation there, that kind of, which I don't even remember now. Like, you know, there are a few things like that which we wouldn't be able to discover ourselves or without 2 years reading all the literature, you know. So, yeah.
Hello. Thank you for this presentation.
Thank you.
I would like to know, during the experiment that you did, have you thought about the quality of the data you were treating?
Quality of what, sorry?
Of data, your data.
There was nothing to, I'll be brutally honest. It was hard to, like, there were good bits and pieces of it, and it was very useful, proved useful for harvest date predictions. But the information that sort of, that is useful for yield predictions were low quality. Lots of repetition, human intervention. So, you know, you wouldn't have to evaluate it. It was a bad, poor quality data set. So have I answered your question all right? Yep, okay.
I have a question.
One more question.
There's another question here.
You use historical data also for your predictive.
What data, sorry?
Historical
Yeah,
data.
yeah.
But you also talk about the climate is changing very much.
Yeah.
Is it still accurate or useful to use that historic data, or do you see situations that we've never seen before and we don't know what the impact is?
Yes, that's a very good question. That's part of the specialty knowledge we had to consult to agronomists. So one thing we figured, we didn't know, we had to, while doing this process modeling, we had to look at the trends in the climate change, and obviously temperature is rising, especially in some regions, and that affects yield. And they told us, aggregate the last 5 years, because before that, you know, it was normal. The last 5 years, we don't know anymore. And that's, again, I'm tying back to the previous question. That's like not doing this and discovering all this and bringing all this information together even is costly. We would like to increase the resilience of our supply chains. We don't want to literally starve because of fires, famines, especially if you think no one expected COVID was gonna hit, and it did, we may well have a famine situation. So we need to really get on top of this business.
I have a question. Here I see that the prediction is looking for ±2-day goal as early as in week 6.
Yeah.
And then the harvest is in week 11.
Yes.
And I was wondering to which extent the prediction that you will make in week 6 will not be impacted by the weather changes during the 6 next weeks. My question is that from the agriculture point of view, does the climate has an impact on this thing after week 6 or not? Because if there is an impact, this means that your result will evolve also.
Yes, so obviously, in fact, the weather has an impact here. If you get a surge of temperature here, you know it is likely that your yield will be low, especially for yield models. So in fact, for this crop, it is more this week, 5 to 6, if I'm not wrong, it was in the first bucket. If you get a high temperature, that affects your predictions here.
Yes, but after not? After week 6,
for
it does
this
not?
one, it does, but within the normal expectations. But if you get a surge here, that literally affects the predictions, and it affects all of it because it is crop growing degree days. It's how much temperature and sun your flower gets. They have crop growth models in their literature, so temperature affects how the crop grows. Temperature and sunlight. That's important here, especially here, and it is stable here. So if you get a hot, as far as I remember, if you get a a very hot day, that doesn't have a high impact on as much as it had here on the yield and harvest date. So that's one of the reasons we are getting good predictions.
Thank you. So thank you.
Thank you very much.
We'll thank our author.